Welcome to General Chemistry 2 class. This section is on acid-base equilibria and salt equilibria. This lesson is about pH calculations. Let's begin. In this lesson, we will calculate pH from the concentration of hydrogen ion or hydroxide ions in aqueous solutions. Here are the equations we learned from the previous lessons. We can see that the concentration of hydrogen or hydroxide ions can be converted to their pH values, pH or pOH, or vice versa. The interrelationship among the concentrations and p-values of hydrogen and hydroxide ions can be illustrated by the following diagram. We will adapt this diagram in our calculations. Example 1. Calculate the pH of a solution containing 8.4 times 10 raised to negative 4 molar hydrogen ion. Solution. We can calculate pH by getting the negative logarithm of the hydrogen ion concentration. Plugging in the concentration gives us pH equals 2.47. Note that the significant digit in pH or pOH are those at the right of the decimal point. The given concentration has two significant figures. Thus, the pH must be rounded off to two decimal places. Example 2. What is the hydroxide ion concentration in a solution whose pOH is 6.84? pOH equals negative logarithm of hydroxide ion concentration. Rearranging equation yields hydroxide ion concentration equals 10 raised to the negative pOH. Substituting the pOH in this equation, we get hydroxide ion concentration equals 1.4 times 10 raised to negative 7 molar. Example 3. What is the pH of a solution which contains 8.43 times 10 raised to negative molar hydroxide ion? We have two ways of solving the problem. The first method involves converting hydroxide ion concentration to hydrogen ion concentration, then converting the hydrogen ion to pH. The hydrogen ion concentration can be calculated from the ion product constant equation. Substituting given hydroxide ion concentration, we obtain hydrogen ion concentration equals 1.186 times 10 raised to negative 11 molar. Only the underlined digits are significant. An extra digit is added to avoid rounding off error in the final answer. Next, to calculate pH, take the negative logarithm of the hydrogen ion concentration, substituting the hydrogen ion concentration. We get 10.926. The pH must have three decimal places, since the given hydroxide ion concentration has three significant figures. The second method involves converting hydroxide ion concentration to pOH, then converting pOH to pH. The pOH is equal to the negative logarithm of hydroxide ion concentration. Substituting the given concentration, we get pOH equals 3.07442. Only the underlined digits are significant. Lastly, the sum of pH and pOH equals 14. The pH is then 14 minus pOH. Substituting the calculated pOH, we get pH equals 10.962. Example 4. Calculate the concentration of hydrogen ion in a solution whose pOH is 2.39. We have two methods by which pOH can be calculated from the hydrogen ion concentration. The first method involves converting pOH to hydroxide ion concentration, followed by converting hydroxide ion concentration to hydrogen ion concentration. Calculate the hydroxide ion concentration from pOH. Hydroxide ion concentration equals 10 raised to the negative pOH. Substitution of the given value yields hydroxide ion concentration equals 4.7 times 10 raised to negative 3 molar. To convert hydroxide ion concentration to hydrogen ion concentration, use the ion product constant equation. Substituting the hydroxide ion concentration gives hydrogen ion concentration equals 2.5 times 10 raised to negative 12 molar. The second method involves converting POH to pH, followed by converting pH to hydrogen ion concentration. The pH can be calculated from the POH using the equation pH plus POH equals 14. Substituting the value of POH, we get pH equals 11.61. No extra digit is necessary to include in the value of pH since the answer is exact. The hydrogen ion concentration is equals to 10 raised to negative pH. Substituting the value of pH, we obtain hydrogen ion concentration equals 2.5 times 10 raised to negative 12 molar. To summarize for aqueous solutions, the following pairs can be interconvertible to each other: hydrogen ion and hydroxide ion concentration, hydrogen ion concentration and pH, hydroxide ion concentration and POH, and hydrogen ion or hydroxide ion concentration and pH or POH. And the references. Thank you.
Acid-base equilibria and salt equilibria. Part 4. pH calculations. Quiz. Matching type. Number 1. Complete the following diagram by matching each item number in column A with the correct equation in column B. Number 2. Choose the correct value for the cell with question mark. A. 9.8 times 10 raised to negative 4. B. 4.8 times 10 raised to negative 5. C. 6.3 times 10 raised to negative 8. Or D. 8 times 6 times 10 raised to negative 5. Number 3. Choose the correct value for the cell with question mark. A. 7.20. B. 9.31. C. 6.83. Or letter D. 4.39. Number 4. Choose the correct value for the cell with question mark. A. 5.84. B. 3.97. C. 7.46. Or letter D. 6.80. Number 5. Choose the correct value for the cell with question mark. Letter A. 2.3 times 10 raised to negative 6. Letter B. 8.9 times 10 raised to negative 6. C. 5.7 times 10 raised to negative 6. Or letter D. 3.9 times 10 raised to negative 6. Number 6. Choose the value for the cell with question mark. Letter A. 7.39. B. 9.64. C. 8.36. Or letter D. 11.58. Number 7. Choose the value for the cell with question mark. A. 9.1 times 10 raised to negative 8. B. 4.4 times 10 raised to negative 9. C. 5.6 times 10 raised to negative 7. Or letter D. 3.8 times 10 raised to negative 4. Number 8. Choose the correct value for the cell with question mark. Letter A. 2.7 times 10 raised to negative 9. B. 3.4 times 10 raised to negative 8. C. 1.1 times 10 raised to the negative 10. Or letter D. 9.7 times 10 raised to negative 13. Number 9. Choose the correct value for the cell with question mark. A. 1.74, B. 6.87, C. 5.69, or letter D. 4.03. Number 10. Choose the correct value for the cell with question mark. Letter A, 9.97, letter B, 1.94, letter C, 8.48, or letter D, 6.56. That would be all. Thank you.